Hello everyone, here is an extra lesson on graphing sine and cosine graphs with vertical translations, phase shifts, and reflections. We're going to start off with the vertical transformation because this is simply the easiest one for us to start off with. So here we have asked to graph y is equal to sine x plus 3. We want to identify the period and the amplitude. Our amplitude is equal to 1. Period is going to be equal to 2 pi because 2 pi divided by 1 is 2 pi. And then we have a vertical shift up by 3. When you have a vertical shift, this is going to tell you where your midline is. The midline occurs at your k value. So we're going to have a midline at y is equal to 3. And because our amplitude is 1, that tells us that our maximum is going to occur at 4 and our minimum will occur at 2. And now we just want to make marks on our x-axis. We have a period of 2 pi, so I'm going to place 2 pi over here. And we always divide into fourths. And then we can start graphing. Since we have a sine function, sine has a y-intercept at the midline, goes up to the maximum, down to the midline, down to the minimum, and then back up to the midline. Now we just need to connect. And there's our graph of sine x plus 3. Next, we will be graphing y is equal to cosine x minus pi over 4 plus 2. Again, we want to identify the amplitude and the period. Amplitude is 1. Period is going to be 2 pi because the coefficient of x is 1. So 2 pi divided by 1 is 2 pi. Now, because we have this minus pi over 4, that's being done to the x, we have a phase shift of pi over 4 units to the right. And we have a vertical shift up 2. Let's set up our graph. Because we have a vertical shift of 2, we have our midline at y is equal to 2. And because the amplitude is 1, there is a maximum at 3 and a minimum at 1. The period is 2 pi, so I'm going to place 2 pi on our graph and divide it into quarters. Now you can graph this one of two ways. So we can graph the function before the phase shift and then shift all the points pi over 4 units to the right. So I'll do that here. So I'm going to first start off by graphing cosine of x plus 2. Cosine has a y-intercept at the maximum. Then it goes down to the midline, down to the minimum, back up to the midline, back up to the maximum. So that is our graph of cosine x plus 2. However, we need to shift all of the points pi over 4 units to the right. Because each tick mark here is a pi over 2, in order to shift it pi over 4, we're going to have to shift it half a unit to the right. So all these points are going to be shifted pi over 4 units to the right. And this is where you're going to have to be pretty good with your fractions just to know how much you need to shift your graph by. And once you shift all your points pi over 4 units to the right, then you want to connect. And there is our graph of cosine of x minus pi over 4 plus 2. Let's see another graph with a phase shift. Next, we're going to be graphing y is equal to 4 sine of x minus 3 pi over 2. Amplitude is 4, period is 2 pi. There is no vertical transformation, so the midline is going to be at the x-axis. That means that because our amplitude is 4, we're going to have a maximum at 4 and a minimum at -4. Now this time I'm going to graph just once, where we'll figure out where the point of 4 sine of x will lie, and then we're going to shift each point 3 pi over 2 units to the right. Each of these squares represents a pi over 2. Then when we are doing our horizontal translation, we just need to shift the points 3 units over. Since we have a sine function that the y-intercept is going to be at the origin, or at the midline. However, we need to shift this point 3 pi over 2 units to the right. So we're going to shift it 3 units to the right, over to 3 pi over 2, 0. Our next point would usually be at pi over 2, 4, but we also have to shift it 3 units to the right, over to here, 2 pi, 4, and then we can just continue the pattern. Our next point would usually be at pi 0, but we need to shift this, or 3 pi over 2 units to the right. So 2, 3 over here at 5 pi over 2, 0, and then we can just continue the pattern. Next, we would go down to the minimum and back up to the midline. And there is our function. Now let's throw a reflection into the mix. Next, we're going to graph -2 sine of 2x plus pi over 2 plus 1. Amplitude is 2, and to find the period, we want to divide 2 pi by our b number, which here is 2. So our period is going to be pi. We have a vertical translation of 1, and we have a phase shift of pi over 2 units to the left. Now, because the period is pi, and I divided the pi into fourths, each of these boxes is going to represent pi over 4, and to shift pi over 2 to the left, we're going to have to move 2 boxes over to the left. So what we're first going to do is we're going to find the points for the function before the reflection, and then we're going to reflect the points over our midline. Our midline is going to be at 1. The amplitude is 2. We have a maximum at 3 and a minimum at -1. And now let's plot the points for the function before the reflection. Sine has a y-intercept at the midline. We have to shift this point pi over 2 units to the left because of our horizontal shift. So this is going to be moved over there. Now for sine, the next point would usually occur right here at our first quarter point. We also have to shift this 2 units to the left over here. And then from there, we can just continue the pattern that we normally have for that sine function. So go down to the midline, down to the minimum, back up to the maximum. And now that we have those points, we just have to reflect it over our midline. The minimum and the maximum values are going to flip. And once you have those points, the reflected points, then you just need to connect it. And there is our graph. Now that's it for our extra lesson. Please let me know if you have any questions. Come to office hours if you need help. I hope you have a wonderful day and take care.